All right. So you're looking to like really get a handle on deep learning performance,
Okay.
specifically like how to benchmark models reliably.
Right.
We've got a deep dive for you all prepped
Awesome.
right into this world of MLPerf.
Okay.
Think of it kind of like the Olympics of machine learning.
Right.
But instead of like athletes, we have algorithms
Yeah.
that are going head to head across all these different tasks,
Mm.
from image recognition to language translation,
Yeah.
and even things like recommendation systems.
It's fascinating how it mirrors like the real world, right?
Yeah,
Just like Netflix knows you have a soft spot for those like classic 80s movies.
totally.
These recommendation systems are getting so sophisticated.
Absolutely.
Yeah.
But
Yeah.
before we jump into like all the specifics of like how it all works,
Yeah.
why do we even need a benchmark like MLPerf in the first place?
That's a great question.
The AI world is like incredibly diverse.
Yeah.
All this different hardware, software,
Yeah.
and even like tiny little implementation tweaks
Right.
can drastically impact performance.
Yeah.
Trying to compare systems without a standardized benchmark
Yeah.
is like comparing apples and oranges.
Exactly.
Like,
Yeah, you're spot on.
yeah,
MLPerf comes in to kind of level the playing field
right.
by like establishing clear rules, standardized tests,
Right.
and a way to like fairly measure how these different systems stack up.
Yeah,
It's about cutting through the hype and getting a clear picture of what works best
totally.
and why.
Yeah, so MLPerf is like a universal translator
Yeah,
for deep learning performance.
exactly.
It helps us make sense of this really complex landscape.
And to understand why this is so crucial,
Right.
we need to look at the sheer scale of AI today.
Okay.
Think about Google alone.
All right.
They handle over 200 trillion queries and 6 billion translations
Wow.
every single day.
Every day, that's a lot.
It's an astronomical amount of data processing,
Yeah,
and it requires incredibly powerful and efficient systems.
that's mind-boggling.
It is.
And to handle that volume, the industry is constantly pushing the boundaries of like
Yeah,
hardware development, right?
absolutely.
The paper that we're looking at mentions that there are over 100 companies
Wow.
developing specialized inference chips,
Really?
compared to just about 20 focused on training chips.
That's amazing.
Like a hardware arms race out there.
It really is.
Yeah.
And each of these systems balances things like latency throughput,
Yeah.
power consumption, and of course, model accuracy
Uh-huh.
in unique ways.
Right.
Take a look at figure 2 in the paper.
Okay.
It shows the like wild west of frameworks,
Yeah.
libraries, and hardware platforms in the ML space right now.
Okay, so we've got this like explosion of AI applications.
Yeah.
This diverse landscape of like hardware and software solutions.
Mhm.
That's where MLPerf steps in
Yeah.
to provide a standardized way to evaluate performance across the board.
Precisely. It's about ensuring that we're comparing apples to apples
Yeah.
when we talk about deep learning performance.
Now, MLPerf isn't like a one-size-fits-all benchmark, is it?
You're absolutely right.
It actually covers a wide range of tasks
Mm-hmm.
that reflect the like diverse applications of deep learning, right?
You're absolutely right.
Yeah.
MLPerf evaluates models on a variety of tasks, including image classification,
Oh,
object detection,
uh-huh.
machine translation,
Right.
recommendation systems. Remember those Netflix recommendations we talked about?
Right, yeah.
Speech recognition,
Okay.
natural language processing,
Wow.
and even generative AI tasks.
That's a pretty comprehensive suite of tasks.
It is.
It really showcases how versatile deep learning is becoming.
Absolutely. And each task comes with its own specific data sets
Okay.
and accuracy targets.
Yeah.
For example, they might use ImageNet for image classification
All right.
or Kokio for object detection.
Oh.
These data sets are like standardized testing grounds for AI,
Yeah.
ensuring that models are evaluated on a common playing field.
So it's like having a standardized curriculum for deep learning.
That's a great analogy.
You need to make sure all the students are taking the same test so you can compare their performance accurately.
Exactly. And it's important to remember that these tasks require different
Yeah.
model architectures and computational complexities,
Right.
which makes a standardized benchmark even more critical
Yeah.
for fair comparison.
So MLPerf allows us to compare how different models perform on these standardized tasks, giving us a clear understanding of their strengths and weaknesses.
Exactly. And it goes beyond just testing in a vacuum.
Okay.
MLPerf uses different scenarios to mimic real-world use cases,
Right.
which gives us a much more realistic and nuanced picture of performance.
Okay, let's unpack these scenarios.
Yeah.
I'm curious to understand how MLPerf brings those real-world applications
Sure.
into the benchmarking process.
Yeah.
What are some examples of these scenarios?
Well, one scenario is single stream,
Yeah.
which is like when you're using voice transcription on your phone.
Right.
It's one query at a time, and responsiveness is key.
So in that scenario, latency or the time it takes to process that single query
Yeah,
is the most important factor.
precisely.
Okay.
Then you have multi-stream scenarios,
Right.
which are essential for tasks like analyzing multiple camera feeds in an autonomous vehicle.
Yeah.
In these situations, you need to be able to handle multiple queries concurrently without sacrificing performance.
That makes sense. You can't have a self-driving car that takes forever to process all the information from its surroundings.
Exactly.
It needs to be able to react in real time.
Absolutely.
Right.
Then there's the server scenario,
Right.
which mimics a cloud service with queries coming in all the time,
Uh-huh.
kind of like a web server handling constant requests.
So in that scenario, throughput or the number of queries the system can process in a given time frame
Yes.
is going to be a key metric.
You got it.
Okay.
And lastly, you have offline processing,
Right.
where you might be analyzing a massive data set, and latency isn't the biggest concern. This is more common in batch processing scenarios where you're working with huge amounts of data
Yeah.
that don't require immediate feedback.
Okay, so MLPerf takes all of these different real-world use cases into account, which makes the benchmarking process much more comprehensive
Exactly.
and relevant to practical applications.
It's about understanding how these models will actually perform in the wild,
Right.
not just in some theoretical laboratory setting.
Yeah, that's really helpful.
Good.
So we've covered why we need MLPerf, the diverse tasks it covers, and the real-world scenarios it uses.
Right.
But there's more to it than just raw speed.
Right. You're absolutely right.
Accuracy plays a critical role as well.
Performance is only one piece of the puzzle.
Yeah.
Accuracy is absolutely critical.
Right.
And MLPerf recognizes this
Okay.
by setting quality targets for each task.
Okay.
These targets ensure that systems aren't sacrificing accuracy for raw speed.
So it's not just about how fast a model can process data,
Right.
but also how accurately it can do so.
Exactly.
Just to strike a balance.
Precisely. And the way MLPerf goes about setting these quality targets is quite interesting.
Okay.
They take into account real-world use cases
Right.
and the expected accuracy levels for those applications.
So, for example, a model used for identifying different breeds of dogs
Yeah.
might have a different accuracy target than a model used for detecting cancerous cells in medical images.
That's a great example.
Right.
The stakes are much higher in the medical imaging scenario,
Yeah, of course.
so the accuracy requirements would be more stringent.
And I imagine these accuracy targets also help prevent developers from cutting corners
Yeah,
just to achieve higher speeds in the benchmark.
for sure.
They have to maintain a certain level of quality as well.
You're spot on. It's about finding that sweet spot
Right.
between performance and accuracy.
Yeah.
Because ultimately what matters is deploying models that are both fast and reliable
Right.
in real-world applications.
Okay. This is really starting to paint a clear picture of how MLPerf ensures a fair and comprehensive evaluation of deep learning models.
Yeah.
But let's dive a bit deeper into how it actually works in practice.
Okay.
Who are the players and how do they submit their results?
Right.
What are the different divisions within MLPerf and what are their purposes?
Great questions. Let's get into it. So you're curious about like the nuts and bolts of like how MLPerf works. It's
Yeah.
like a well-organized competition, where everyone plays by the rules.
Okay.
MLPerf has two main divisions,
Okay.
closed and open.
Okay, let's break those down.
Yeah.
What's the difference between the closed and open divisions?
So the closed division is all about strict rules and like a level playing field.
Okay.
Everyone uses the same data set.
Right.
And model implementation.
Yeah.
So it's like comparing apples to apples.
Right.
It's designed for direct head-to-head comparisons
Okay.
between different systems,
Yeah.
eliminating like any ambiguity that might skew the results.
So it's like the gold standard for measuring performance.
Yeah, you could say that.
Because everyone's working with the same set of constraints.
Exactly.
What about the open division? What's its purpose?
So the open division is more about fostering innovation and pushing the boundaries
Okay.
of what's possible in deep learning.
Right.
Participants can use different data sets, model architectures,
Huh.
and optimization techniques.
Okay.
It's a space for exploring new ideas and approaches where you might see cutting-edge models or novel hardware architectures being benchmarked.
So it's a glimpse into the future of deep learning,
Yeah.
where researchers and developers can experiment and see what works best without being restricted to a specific set of rules.
Exactly. And both divisions have their own value within the MLPerf ecosystem.
Okay.
The closed division provides like rigorous apples-to-apples comparisons,
Okay.
while the open division is where you see the sparks of innovation.
Right.
It's a beautiful balance between standardization and exploration.
I'm starting to grasp how MLPerf caters to both the need for reliable comparisons
Yeah,
and the drive for innovation in the field.
exactly.
But let's say a team wants to submit their result to MLPerf.
Okay.
What does that process involve?
So a submission typically includes several components.
Okay.
You have the system under test,
Yeah.
which is the hardware and software being evaluated,
Right.
a load generator that simulates different scenarios we talked about earlier, the data set for the task,
Right.
and an accuracy script
Okay.
to verify that the model meets the required quality targets.
So it's like a comprehensive package
It is.
that ensures everyone's on the same page
Yeah.
and that the results are credible.
It's really impressive how MLPerf has like thought through all these details to make the benchmarking process as robust as possible.
Absolutely.
And to maintain fairness, they have what are called model equivalence rules.
Okay.
These rules allow for efficient reimplementation on different architectures. While ensuring everyone's playing fair,
Right.
you can't game the system by optimizing your model for the benchmark.
Right.
It's about measuring real-world performance.
That makes a lot of sense. It's like having a referee in a sporting event
Right.
to make sure everyone's following the rules and that the competition is fair.
You got it. And another critical component in all of this is the load generator.
Okay.
It's like the conductor of the orchestra,
Right.
generating query traffic and collecting data according to the selected scenario.
Okay.
It ensures that the tests are conducted in a way that accurately reflects real-world usage.
So it's not just about throwing random data at the model.
No.
It's about creating a realistic workload
Yeah.
that mimics how the model will be used in practice.
Exactly. The load generator plays a crucial role
Yeah.
in ensuring that the benchmark results are meaningful
Right.
and applicable to real-world scenarios.
That brings us to another crucial aspect of MLPerf,
Okay.
one that's becoming increasingly important in the real world: power consumption and energy efficiency.
Absolutely. As deep learning models become more complex and computationally demanding, the energy they consume is a growing concern,
Yeah.
especially with the rise of those massive language models that
Right.
everyone's talking about.
Those models can be real energy hogs.
They can't.
And it's not just about the cost of electricity.
Right.
There's also the environmental impact to consider.
Precisely, the carbon footprint of training and running these models is becoming a significant issue, which is where MLPerf power comes in.
Okay.
It's all about measuring and understanding the energy consumption of different deep learning systems, bringing energy efficiency into the spotlight
Yeah.
alongside performance and accuracy.
It's like adding another dimension to the evaluation process,
Exactly.
recognizing that energy efficiency is no longer an afterthought,
Right.
but a critical factor in assessing the viability of deep learning models.
You're absolutely right. And the challenge here
Yeah.
is that the power requirements of deep learning systems can vary dramatically.
Okay.
We're talking about a spectrum ranging from microwatts for tiny embedded devices
Wow.
to megawatts for massive data center clusters.
That's an incredible range.
It is.
How does MLPerf power even begin to measure power consumption across such a diverse set of systems?
It's a good question. They use different approaches depending on the scale of the system.
Right.
For large-scale data center systems, they might use standard power meters that measure total energy consumption over time.
Okay.
But for smaller systems like edge devices or tiny embedded systems, they need specialized equipment that can measure current and voltage directly, allowing them to calculate power consumption with high precision.
So it's about using the right tool for the job.
Yeah.
Recognizing that you need a more sensitive instrument to measure the energy consumption of a tiny device compared to a massive data center. What about those extremely low power systems, the ones that consume just a few microwatts?
Yeah, those are tricky.
How do they measure that?
That's where things get really interesting.
Okay.
They use a technique called parasitic power measurement.
Okay.
They isolate the system under test from external power sources and measure the tiny amount of power it draws from the measurement equipment itself.
Oh, wow.
It's like measuring the energy a mosquito steals when it bites you.
That's a very vivid analogy, but I get the idea.
Okay.
It's incredible how they've developed these techniques to measure energy consumption across such a vast spectrum.
Yeah, it's quite impressive.
But what have we learned from these measurements?
Okay.
What are some of the key insights that have come out of MLPerf power results?
One of the key takeaways is that there's a strong correlation between model complexity and energy consumption.
Okay.
As models become larger and more complex, they tend to require more computational power, which translates into higher energy usage.
That makes intuitive sense. More complexity, more energy.
Right.
But are there any silver linings? Are we seeing any improvements in energy efficiency?
There are.
Okay.
As models become more sophisticated, we're seeing significant improvements in the energy efficiency of newer models.
Okay, that's good.
Particularly in generative AI.
Okay.
While those large language models can be energy hungry, they're becoming more efficient over time.
Okay.
Partly due to advancements in hardware architectures and software optimization techniques designed to reduce energy consumption.
So it's like those energy efficient appliances that use less power to do the same job.
Exactly.
That's reassuring to hear. Are there any other interesting findings from MLPerf power?
One interesting finding is that certain tasks are inherently more energy efficient than others.
Interesting.
For example, image classification models tend to be more efficient than object detection models, even when they have similar levels of accuracy.
Why is that? Is it related to the complexity of the task itself?
Exactly. Object detection involves not only identifying objects in an image, but also locating them precisely with bounding boxes. This requires more processing power and therefore more energy.
I see.
It highlights the importance of choosing the right model and architecture for the job. If energy efficiency is a priority, you might opt for a simply model that can still achieve the desired level of accuracy.
It's about making those smart trade-offs.
Exactly.
Considering both performance and energy efficiency when selecting a model for a specific task.
Exactly. And while we're seeing progress in energy efficiency, there are still challenges ahead. One concern is the efficiency plateau observed in edge and tiny ML systems.
So we're hitting a wall with efficiency in tiny devices.
Kind of, yeah.
What are the implications of that?
It's a major challenge because these small, low-power systems here are essential for applications like the Internet of Things and mobile devices. If they're not energy efficient, it could significantly impact battery life cost and even the environment.
So this efficiency plateau poses a real problem for the future of ubiquitous AI.
It does.
Where we want to deploy these tiny intelligent systems everywhere. What are some potential solutions to break through this barrier?
Well, we might need to explore new model architectures that are inherently more energy efficient or develop new hardware platforms optimized for low power operation.
It sounds like we need some breakthroughs in both hardware and software design.
We do.
To overcome this hurdle.
Absolutely. And MLPerf Power will be instrumental in guiding these efforts. By providing a benchmark for measuring and comparing energy efficiency. It's like a compass pointing us in the right direction as we navigate this complex landscape.
That's a powerful analogy. So MLPerf is not just a static set of benchmarks.
No, it's not.
It's a dynamic force that's shaping the future of deep learning by pushing for both performance and sustainability.
Absolutely.
We've covered so much ground already.
We have.
From understanding why we need MLPerf to exploring its various divisions, tasks, scenarios, and even its focus on energy efficiency. But I'm curious to hear your perspective on the bigger picture. What does all this mean for someone who wants to truly understand and work with deep learning effectively?
Sure.
What are the key takeaways from our deep dive into MLPerf?
It's been a fascinating journey through the world of MLPerf.
It really has.
I think the key takeaway is that MLPerf provides this much-needed framework for understanding deep learning performance. It's about cutting through the noise and marketing hype to get like a clear, objective picture of how different models and systems stack up against each other.
You're absolutely right. It's like having a Rosetta Stone for deciphering this complex language of deep learning performance claims.
Exactly.
But it's more than just understanding the numbers. It's about grasping the nuances, the trade-offs, and the context that truly matter when you're evaluating deep learning systems for real-world applications.
Precisely a model that achieves a record-breaking score on one benchmark might be completely unsuitable for a different task or scenario.
Right.
That's why MLPerf's comprehensive approach with its diverse tasks, realistic scenarios, and focus on both performance and accuracy is so valuable.
It is.
It provides this holistic view that's essential for making informed decisions about which models and systems are right for the job.
It's like having a toolkit for navigating the complexities of deep learning.
Yeah.
MLPerf gives you the instruments you need to measure performance accurately, to compare different approaches, and to understand the strengths and weaknesses of these various models and systems.
Exactly.
It's incredibly empowering for anyone working with deep learning.
It is.
Whether you're building models or designing hardware or simply trying to understand the capabilities of different AI systems.
I couldn't agree more. And one of the aspects of MLPerf that I find most compelling is its focus on real-world scenarios.
Yeah.
The different scenarios like single-stream, multi-stream server, and offline.
Right.
They capture the diverse ways deep learning is being used today.
Yeah.
It's not just about testing models in some artificial environment.
Right.
It's about understanding how they'll perform in the wild under real-world conditions.
That's a critical point.
It is.
It means that the results from MLPerf are directly applicable to practical situations.
Yes.
You can have confidence that a system that performs well in MLPerf will likely perform well in your production environment.
Exactly. And this focus on real-world relevance extends to energy efficiency as well.
Yeah.
MLPerf Power, with its meticulous measurement techniques and comprehensive analysis, is shining a light on the energy footprint of deep learning, pushing for greater sustainability in the field.
That's crucial. As AI becomes more pervasive and models continue to grow in size and complexity,
it is.
We need to be mindful of the environmental impact of deep learning and strive for solutions that are both powerful and efficient.
Absolutely. It's about finding that balance between performance and sustainability. And MLPerf is helping us navigate that landscape by providing the tools and insights we need to make informed choices.
As we wrap up our deep dive into MLPerf, I want to emphasize that it's a constantly evolving benchmark.
It is.
It has to be.
It does.
The field of deep learning is advancing at an incredible pace.
It is.
And MLPerf is constantly adapting to keep up with the latest trends and challenges.
You're right. It's a living benchmark, constantly evolving to reflect the state of the art in deep learning.
Yeah.
And I think that's one of the most exciting aspects of MLPerf.
Yeah. What are some of the trends you see on the horizon for MLPerf?
Okay.
What new challenges and opportunities do you anticipate?
I think one of the most interesting areas is the development of benchmarks for specific application domains, like healthcare, finance, or manufacturing.
Yeah.
These specialized benchmarks will provide even more relevant insights for those industries, tailoring the evaluation process to their unique needs and challenges.
That makes a lot of sense. It's about making MLPerf even more useful and impactful by creating benchmarks that are finely tuned to the specific requirements for different fields.
Yeah.
And I imagine there'll be a growing emphasis on benchmarking for responsible AI.
Oh, for sure.
Evaluating factors like fairness, robustness, and explainability.
Absolutely.
As AI systems become more integrated into critical applications, it's essential that they not only perform well, but also behave ethically and responsibly.
Absolutely. We need to ensure that AI is a force for good in the world.
Yeah.
And MLPerf can play a crucial role in that effort by providing the tools and standards.
Right.
We need to evaluate and promote responsible AI development.
Well, I think that's a fantastic note to end on.
It is.
MLPerf is like a vital resource for anyone who's serious about understanding and advancing the field of deep learning.
I agree.
It provides a framework for evaluating performance, driving innovation, and promoting responsible AI development.
Yeah.
It's a beacon of clarity in this complex and rapidly evolving field.
I wholeheartedly agree. Keep exploring the world of MLPerf. Stay tuned for new developments, and remember to benchmark responsibly.
That's a wrap for this episode of The Deep Dive.
Awesome.
We hope you found this exploration of MLPerf informative and insightful.
Me too.
Until next time, keep those deep learning engines running.